So let's do this division here. We want to divide this polynomial here by this polynomial, and what we'll do is we'll do it the normal way that you're probably used to seeing a division. But then after that we'll go into a simpler way of doing it called synthetic division. So first of all, let's look at an example of division. So let's say for example we were dividing the number, say 43, by the number 7. Then we would say 7 goes into 43 6 times. 6 times 7 is 42. Then we would subtract these off and we'd be left with a value of 1. So that would mean that 7 would get into 43 6 times and there would be a remainder of 1. So let's do the division in the same manner here. If I was to divide this into this here, well, first of all I could multiply this by 5x squared and this would give us the 5x cubed. So we put the 5x squared here. So that's 5x squared. Now whenever we multiplied that, that's going to give us our 5x cubed minus a value of 10x squared. Now what we can do is we can subtract those off in the same way we subtracted them off here, so that would give us zeros and this would give us a value of that minus that becomes plus, so that would be a value of 12x squared. And then we could bring down the next value here, which is our plus 8x, and we could do the division again. So if we were to multiply this here by 12x, we'll get a 12x squared. So this will be plus 12x. So that will give us our 12x squared. And if we multiply this here, it will give us our minus 24x. So again we can subtract these off, that gives us 0, and this here gives us 32x. Then we can take down our next value here, which is our minus 2, and we can multiply this again by 32, so we'll have plus 32 here. So that's going to give us our 32x minus 2 times the 32 is going to give us our 64, and we can subtract these off again. That minus that is 0, and that minus the negative of that is the same as that plus that, which will give us a value of 62. So that means that whenever we divide this into this, we get a value of 5x squared plus 12x plus 32, and the remainder is 62. And the same as we had done, it's the same as we had done here. And this is finished off a little bit more neat and tidy. Now we want to look at a bit of terminology here for each of these values, so we'll go and look at that next. So if we just rewrite this little equation out here, 43 is equal to 7 times the 6 plus the 1. Now we call the 7 here the divisor, we call the 6 here the quotient, and we call the 1 down here the remainder. So you can take a note of that up here. We have the divisor, we have the quotient, and we have the remainder. So in this instance here we can see that the divisor is x minus 2, the quotient is 5x squared plus 12x plus 32, and the remainder is 62. So that's a long-winded way of going about this. What we want to be able to do is find a quicker way of doing this division, and we're going to do that with something called synthetic division. So let's go ahead and we'll get that done now. So here's the process of synthetic division. We've got the same problem that we had above, so that's the one that we've just done. Okay, Now what we're going to do is just the same as we'd done in the previous video when we were finding the value of a function. So we'll draw this out in this format here, and we're going to be taking the coefficients of each of these terms. So the coefficient of x cubed is the 5, the coefficient of x squared is the 2, the coefficient is the 8, and this value here is minus 2. Now this x minus 2, what we're interested in is the value whenever y is equal to 0. So we're interested in x minus 2 equals 0, therefore x must equal a value of 2. So I could write that here. X minus 2 equals 0, therefore x must equal 2. Okay, so we've got this value 2 here, and we're starting off with 5, and we say 2 times 5 is 10, plus the 2 is 12. And then 2 times 12 is 24, plus the 8 is 32. And then you say 2 times the 32 is 64. 64 plus negative 2 is a value of 62. So again, we've got this remainder here, which is 62. But we've actually got the quotient here as well. We've got the value of 5, so that's going to be 5, and it will be x squared, and it will be 12 plus 12x plus a value of 32. So you can see here that we've actually gone through this little process. We've actually done our division, and we've got our quotient here, we have our remainder here, and we have our divisor up here. So that's a much quicker way of working through the division, and just to convince yourself, that's 5x squared plus 12x plus 32. Well, that's the same as what we have up here, 5x squared plus 12x plus 32. So synthetic division is a much quicker way for us to work through and divide out polynomials. So we can go ahead and we can put our quotient up the top. So that's the same, that's 5 x squared plus 12x plus 32. Now again, we can actually check and see that this is correct, because what we can do, if we multiply this with this, we should get back to this value here. So let's just have a quick look and we'll see. Of course we will have a remainder as well, so we'll have to add the remainder on as well. So we're going to have our x minus 2, and we won't multiply the whole thing out, we'll just do it for the constant term at the end and see that it does actually match up. So x minus 2 times 5x squared plus the 12x plus the 32, and we're saying that the remainder is going to be 62. So what we're saying is this thing here should be the same as this thing here, but we'll just check the very last term. The last term should be minus 2. Well, you're going to have minus 2 times 32, which would be minus 64. So minus 64 plus the 62 would be minus 2. So it does match up. So don't worry too much if you're not following this completely. It's best seen by example, and we'll go through a few examples over the next video. So thank you for listening, and I'll get you in the next video. Goodbye.